Well, hi class. So we're getting near the end. This is our second to last lecture. And this, we're still working on chapter 20. And this is the fourth lecture in chapter 20, and it's on functional groups. And what you see on the screen is the worksheet we're going to be working on. It's worksheet 39. Yours actually looks better than this one. Anyway, we'll finish this. It's a rather short worksheet, and I think this is a rather short lecture. So let's get started. So here's our slideshow. And come on, there we go. All right, so our learning goals in this lecture is to define and differentiate between functional groups. So this is just an introduction also. So there are a lot more functional groups that are out there than what we're going to talk about today, but these are the main ones. So these are the main ones. So second goal is to recognize structures of different functional groups, and that'll be part of the worksheet. Draw structures. I'm not sure if I'm going to have you draw any, but you should be able to draw these. And then lastly, know the names of the different functional groups, at least the ones that we're studying here. The different functional groups that we're looking at today are described in chapter 20 in section 20.2, 20.3, and 20.4. So, but in those sections, they also talk about how you make those types of functional groups. And also the different chemical reactions that they can undergo. So we're not going to go into that. Basically, I just want you to be able to recognize them, be able to draw them, be able to identify them if you see a chemical compound. So what are functional groups? They're actually the different families of organic compounds. And there's sort of a hierarchy. So if they go from a lower hierarchy to a higher hierarchy, if you will. And these, later on, I'm going to show you compounds that have multiple functional groups. And so you would, because of this hierarchy, there would be, if a compound contains more than one functional groups, it would be named, the family it would be in would be according to the functional group, the highest hierarchy, if you will. So we're actually not going to learn that today, but there is sort of a hierarchy in functional groups. And the way we're going to learn them, we're going to learn them kind of from the lowest, the least hierarchical, well, I can't even say it, but the kind of the lowest functional group to the higher functional group. So that's how we're going to learn them. So each functional group has specific properties and reactivity. I have this underlined because that's the most important thing about functional groups. So they classify organic compounds in different families, but what's really important is the properties that they confer on the molecule and their chemical reactivity. We want to understand the properties, let's see, to understand the properties and reactivity of many organic compounds, you only need to identify the functional group in that compound. But if it has multiple functional groups, if a compound has multiple functional groups, you have to consider the properties of each of those, and one property might be dominant. So that's the one that's going to determine the property of the molecule. So let's see. So alkanes, first of all, when we talk about functional, alkanes are not a functional group. So we talked about alkanes before, like CH4. It's the CnH2n plus 2 types of compounds. So alkane is a family, but it's not really a functional group because they're not very reactive. And The one thing about functional groups is that they do provide a point of in a molecule where you can change that molecule, a place where you can do a chemical reaction on that molecule. In the case of alkanes, they're all carbons and hydrogens, it's all single bonds. There isn't really a handle in an alkane where you can do a reaction and change that alkane. Even though there are some reactions that alkanes undergo, but they're not generally considered a functional group. The one thing that alkanes do well is they burn. Remember, we looked at propane and methane and butane. Those are all in gasoline. Those are all hydrocarbons. So one thing hydrocarbons do well, especially alkanes, is that they burn. Okay, so let's talk about how you make a functional group. But you make functional groups from alkanes. So an alkane is, or a functional group occurs when one carbon on an alkane is changed. So you might add an oxygen to it, a nitrogen to it. You might add a double bond between two carbons. So those are how you introduce functional groups into an alkane molecule. So the simplest functional groups, though, the lowest hierarchy, they are hydrocarbons, and they're modified alkanes. And these are called the alkenes, the alkynes, and the aromatics. And I think we've talked about some of these. We talked about alkenes and alkynes before. Remember, the alkene has a carbon-carbon double bond. We'll look at that in a minute. And the alkyne has a carbon-carbon triple bond. And the aromatic is a cyclic. This is a cyclic molecule, special cyclic molecule. It's a cyclic hydrocarbon. So most functional groups, though, contain other carbons other than carbon and hydrogen, contain atoms other than carbon and hydrogen. And these other atoms are called heteroatoms. And so that could be oxygen, nitrogen, sulfur, phosphorus, and the halogens. These are all considered heteroatoms because they're not carbon or hydrogen, really carbon. So these are atoms that have replaced a carbon or a hydrogen in a molecule. So here's our first functional group. This is number one, the first one we're going to talk about. Number one, alkenes. And alkenes are molecules we talked about previously that have a carbon-carbon double bond in them. And here's just three different alkenes, or four, I guess. We have ethene, or ethylene is the smallest one. You have to have at least two carbons. So there has to be the number of carbons, we'll say N, has to be greater than or equal to 2. So we have alkenes here, 2 carbons, 3 carbons, 4 carbons. And in the case of 2-butene, you can have sister trans. We talked about the sister trans isomers in that case. So we have 2 molecules here, and this representation doesn't indicate whether we're talking about sister trans. Another functional group, this would be number 2, are alkynes. And this is another hydrocarbon functional group. And that would be where you have a triple bond between 2 carbon atoms. To form that triple bond, you have to take away 2 hydrogens. So if you start with something like this, with 3 C2H6, and you remove 2 of the hydrogens, you can form a double bond. If you remove 2 more, you can form a triple bond. So these kinds of compounds, the alkenes and the alkynes, are called unsaturated compounds. We've taken away hydrogens. We've created, remember the alkanes are called saturated. When you remove hydrogens from 2 carbon atoms and make the double or triple bond, you've created a point of unsaturation. And what this is a place where you can do some chemical reactions. So there are lots of chemical reactions you can do. You can add stuff to this triple bond. Lots of things you can do to that triple bond. you can add back the hydrogen to make an alkane again, for one thing. And that is commonly done. So to alkenes and alkynes, that's a reaction. So these kinds of molecules occur naturally in oil. So petroleum, natural oil, the crude oil contains lots of hydrocarbons, a huge mixture of hydrocarbons. So when they refine them, they actually do a distillation and collect the different hydrocarbons by their different boiling points. That's a major function in a refinery. So a couple things about when you make a double bond or a triple bond between carbons, that bond is stronger. It's like because you've got more bonds holding it together. So the bonds are shorter. They get shorter and shorter as you go from a carbon-carbon single bond, carbon-carbon double bond to carbon-carbon triple bond. But it's more reactive. So the bond's stronger, totally stronger because it's 3 bonds, but it's more reactive because you have in the carbon-carbon single bond. Okay, the third type of hydrocarbon functional group is called an aromatic, and that's the simplest aromatic is called benzene. So that's right here. Benzene has the molecular formula C6H6. So there are hydrogens on each of these. So I could write these in. So if you have a C6H6, you have a benzene, and you have alternating double bonds in a cyclohexane ring. Well, that confers, we haven't talked about it, but that if you look at molecular orbital theory, remember, so each of these is sp2. Each carbon in that ring is in sp2. But that confers particular stability on the benzene ring. So even though, so the benzene ring doesn't act like, it looks like a cycloalkene, and that's what chemists thought it was originally, but it really is has more stability. It's more stable than cycloalkene. So the chemical reactions that occur with benzene rings are different from the chemical reactions that occur with alkenes. So they're a whole separate class of compound. And so you can have substituted benzene rings. And anyway, benzene ring, so if you have a benzene ring attached to something else, I'll put an R here, to another chain. So oftentimes you'll see R's used, that's a generic symbol for something attached to the benzene ring. It can be anything. It could be a benzene ring attached to polymer, or it could be a polymer. But the benzene ring, so you can draw the alternating double bonds 2 ways. Oftentimes you just draw a 6-sided ring with a circle in it to represent the benzene ring. This is called an aromatic functional group. So a benzene ring is aromatic, and an aromatic group is often called aryl. This isn't the only aromatic group. You can have, there's lots of other ones. You can have fused benzene rings. So there's another one called like this, ring there. You can put 2 rings like that and then have that attached. That's another aromatic functional group called an aphthol. And anyway, the generic term for an aromatic group is called aryl, but the benzene ring itself has a special name. It's called a phenyl, P-H-E-N-Y-L. And the symbol, instead of drawing a whole benzene ring, you can just draw a phi for the phenyl group. So if we wanted to show a benzene ring attached to the R, we could do like this. Okay, that's a lot faster than drawing a benzene ring. So the benzene ring is a functional group, is called a phenyl. Aryl means just aromatic, and there are lots of aromatic functional groups. But the benzene ring specifically is a phenyl. An unsubstituted benzene ring is a phenyl, and it uses a phi or a phi, a Greek phi lowercase, as a symbol to represent that. So that's a really shortcut, and I'll mention that again later at the end. Okay, so we're going to go on past hydrocarbons. Those are hydrocarbon functional groups. Now, if you replace a hydrogen in an alkane, remember we're talking about replacing carbon atoms are doing something to a carbon atom to the hydrogens in an alkane to get these functional groups. So in the case of, if we take a hydrogen off and replace it with a halogen, remember halogens are always singly bonded to carbons, we get an alkyl halide, and that's shown here. So that's our fourth functional group, number 4. And if we take a hydrogen off and replace it with an OH, which is called a hydroxyl, I'll mention that, you get an alcohol, it's number 5. If you take a hydrogen off and replace it with an SH, you get, it's called a thiol, number 6. Now notice that the sulfur has 2 bonds to it. It has 1 bond to the carbon, 1 bond to the hydrogen, same with the oxygen, 1 bond to the carbon, 1 bond to the hydrogen. If you take off the hydrogen and replace it with a nitrogen, you get an amine. Now the amines, there's 3 kinds of amines. Excuse me, there's also 3 kinds of alcohols. Sorry about that. So the alcohol is an OH connected to a saturated carbon atom. So we have 4 bonds, 4 single bonds to that carbon atom. That's sp3 carbon atom. If you have an OH attached to an sp2 carbon or an sp3 carbon, it's a different molecule. It's not called an alcohol. So the OH attached to an sp3 carbon, but that sp3 carbon can be attached to another carbon. So if the carbon has 2 single bonds, so the alcohol 2 single bonds, it's called a primary alcohol. If it's connected to a carbon atom with has 2 carbon atoms, it's called a secondary alcohol. And if there's 3 carbon atoms, it's a tertiary alcohol. So we have 3 different alcohols. The same for amines. If there's only 1 carbon, so it's a saturated carbon, and you have the carbon attached to another carbon, then you have a primary amine. Oh no, wait, that's not correct. Okay. There are primary, secondary, tertiary amines, but they're different. So the primary amine is N with 1 carbon. Remember, there's 2 other bonds to nitrogen. If you have another carbon here, it's called a secondary amine, and this would be a tertiary amine. So they're all amines though. So a nitrogen connected to a carbon makes an amine. An OH connected to carbon makes an alcohol. So it's OH and it's just a nitrogen. So the nitrogen can be an N with, could be NH2, can be NHC, or N with 2 Cs. If you stick an oxygen in between 2 carbon atoms, you get an ether. So these are the 3, these are what, number 5, 6, number 7, number 8 functional group. So something else. So the OH is called a hydroxyl group. And that's important. There's lots of functional groups that have OHs. There are other functional groups that have OHs, I should say. We're going to talk about one other one, but there are more than that. The SH is called the thiol group. And again, you can use the SH combined with these groups of atoms. So an OH is hydroxyl, SH is thiol, NH2 is called an amino, and we're going to learn a couple of others. And you can combine these subgroups, if you will, to form functional groups. So this is just the first slide that shows these subgroups. So hydroxyl, thiol, hydroxyl and amino are the most important on this page. That one and that one. Okay, so let's look at a few more functional groups. Let's see from that page. So we have number 8, number 9 is called an ester, 10 is an amide, 11 is a nitrile, 12 is a ketone, 13 is an aldehyde, 14 is a carboxylic acid. So all these functional groups, most of them anyway, we've got this new group, subgroup showing up. And this subgroup is called a carbonyl. So let me show those. So the C double bond O is a carbonyl. So what we've done is we've removed 2 hydrogens from a carbon and added this double bond O. So you can sort of think of this ester. Remember this part here looks like an ether, but if we take off 2 hydrogens that the ethers, when the O is connected to, and put a double bond O, you end up with an ester. The names are pretty similar. It's pretty easy to confuse an ester and an ether, so you have to be careful. You know, a good way to learn these is to make flashcards. So flashcards for functional groups work really well for learning them. You don't have to memorize them for the exam or for the worksheet because you have your sheets to look at, you know, with all the functional groups. I'll show you those in a minute. Similarly, if you have a carbonyl, so if you have an amine and you add a double bond O, you get an amide. So let's go back. Let me go back a little bit to the previous page. So here's our amine here. I wonder if I can clear the picture somehow. Let me see. No. Okay, so maybe I can't. I don't know how to. Oh, if I go like this, let's see. Oh, yeah. I think this is eraser. Oh yeah, I can erase. Good. Okay, so look at the amine. We're going to take away this hydrogen. We're going to take away these 2 hydrogens. And we're going to add a double bond O. So we take away 2 hydrogens. We add a double bond O. And actually there is still one bond there. You get an amide. Okay, so let's go back to the next page. Here's our amide. We put a double bond O there. Same, if you take an ether, you put a double bond O on the carbon that the O is attached to, you get an ester. This nitrile is more of a compound where we've taken away 3 hydrogens and added a triple bonded N. So it's somewhat related to an amine. In fact, you can take an amine, a primary amine, and you can remove the hydrogens and you get a nitrile. So if we go back here to our primary amine, let's see. Let me get all this stuff. Here's our primary amine. And we take away these 2 hydrogens and put a triple bond here, you get a nitrile. Okay, that's this one down here. Okay, what's a ketone? Well, a ketone is where you have just an alkane, you take away 2 hydrogens and you add a double bond O, and you get a ketone. So that's a carbonyl inserted, if you will, between 2 carbons. An aldehyde is a carbonyl inserted at the end of a chain. So if you have a CH3 and you take away 2 hydrogens and put a double bond O, you get a carbonyl. It doesn't have to be inserted or added to the end of a chain. It could just be, you know, you've replaced a double bonded oxygen for 2 hydrogens at the end of a chain. And lastly, a carboxylic acid you can think of as being derived from an alcohol where you take away 2 hydrogens on the alcohol and put a C double bond O. So maybe if I draw this here, if we have a C, we have some hydrogens here, we have an OH, we have an H here, and an H here. And then we take away these 2 H's and put a double bond O. We get a carboxylic acid. And that's actually how they're synthesized. That's called oxidation. So you can take an alcohol, primary alcohol, you oxidize it, and you'll get a carboxylic acid. And I think it does mention that in your textbook. So we're not going to worry about those reactions, but that's how you form these. So that gives us 14, and there's a couple of subgroups here that I want you to be aware of. The C double bond O is called a carbonyl. The C triple bond N is a cyano. And the COO with a couple of other bonds there you can attach things to is called a carboxy group. So these, the carboxy you see in carboxylic acids, and you see carboxys in esters. The carbonyl you see in carboxylic acids, aldehydes, ketones, esters, and amides. And those are important. So these types of groups, like the carbonyl and the cyano, they have specific reactivities and properties also. So lastly, I wanted to show you how some of these functional groups are condensed. So there are other kinds of representations, maybe a condensed structure. So in the case of an aldehyde, you can write it as a CHO, a CHO. So if you ever see a molecule, a condensed structure written, and you see CHO at the end, that means it's an aldehyde functional group. Carboxylic acids are condensed down into COOH or CO2H. And then, like I said previously, the benzene ring is called a phenyl, and it's condensed down to this little phi or phi. So this just shows a summary of all those functional groups. There's a couple of others here. If you add amines or bases, they're organic bases. So the conjugate acid of the amine is called an ammonium. So you put an H, remember the conjugate acid, the amine being a base, it's going to pick up a H plus. When it picks up the H plus, it becomes an ammonium, and that nitrogen has a plus charge. So you often see those in tune with an amine. So the amines are the bases, or organic bases. That's an important property for amines. So I'm going to write that down. Amines are organic bases. And carboxylic acids, of course, are acids. So you can react a carboxylic acid with an amine, and what you'll end up with is an ammonium, which is the conjugate acid of the base. You'll end up with a carboxylate anion, which is the conjugate base of the acid. So this last slide says that compounds frequently have more than one functional group. So that does a couple things. It makes everything a lot more complicated, but it also makes for more interesting compounds. And I have a couple of examples here, and these are all natural occurring compounds. So we have testosterone, phenylalanine. So we know testosterone is a sex hormone, and this is called a steroid. This is a steroid. These four rings, fused rings together, makes a steroid. And biologically, there are lots of steroids in our bodies. So the sex hormones are steroids, and cholesterol is a steroid. You know, that's kind of has a bad rap, but cholesterol is important. And cortisol, that's a steroid. Lots of you've heard of steroids. There's anabolic steroids that weightlifters like to use to make their muscles bigger. They all have this structure. This is the core structure of a steroid. Phenylalanine here, that's an amino acid. So there's 20 important amino acids in our bodies. And in most biological systems, there are 20 amino acids. And then down here, we have a compound called dihydroxyacetone phosphate, which is a intermediate compound in the metabolism of glucose. So let's look at these. So in testosterone, there's a ketone right there. It says ketone. There's an alkene, and there's an alcohol, secondary alcohol. In phenylalanine, there's an ammonium and a carboxylate. And in dihydroxyacetone, there's a phosphate and primary alcohol and a ketone. So these are, when you put these functional groups together in one molecule, you get some really interesting and important compounds. So that's it. I'm going to go switch over, stop the share. We'll look at this, the worksheet. So our worksheet here is on functional groups. And I've summarized the functional groups here. And there's, I'll just let you read this. This is a good reference for functional groups that you can take with you. And the reference part is 3 pages long. So there's lots of functional groups here. There's actually more than we talked about. And I think at the very beginning, I told you this is just an introduction to functional groups. There are a lot more. And you can look at this handout to see some others. So let's look at the first question. What I'm going to do on this worksheet, I'll do every other one, and I'll have you do the others. So I'll do A and C, and you do A and D. And then the same on the problem 2. I'll do A. Oops. I'll do the opposite. I'll do B, D, and E. The ones that I circle here on this are the ones I want you to do. All right. So let's start. So I'm going to do the ones that are not circled. So a carbonyl group, remember carbonyl, and I'll draw what a carbonyl is. A carbonyl group connected to at least one hydrogen. So we have a carbonyl connected to one hydrogen. And what is that called? Excuse me, that's called an aldehyde. Okay, so that's the answer to the number 1. I want to do number 3, a benzene ring bonded to a hydroxyl group. So we have a benzene ring bonded to a hydroxyl group. So I'm going to combine 2 things. I'm going to call this an aromatic. There's 2 functional groups here. This is an aromatic alcohol. And this particular alcohol is a special name. It's called a phenol, but I don't want you to know the names. But we could name this as an aromatic alcohol. So there's 2 functional groups there. So you do B and C. And I think, I'm not sure, this might be one of the worksheets I want you to turn in. So now I'm going to do, so the question 2 says, list all the functional groups other than alkane in each of the following structures. So B has an aromatic, and I'll just circle. So we should identify the functional group by circling it or indicate where it is. And this is an aromatic. It's not a benzene ring because a benzene ring doesn't have any substitutions. If that CH3 wasn't on there, then it would be a benzene ring. We could call it a phenyl. But anyway, it is an aromatic because it has the 6-sided ring with alternate double bonds. Okay, let's look at D. So D looks like it has NH2, but the NH2 is, I'm going to zoom into this so you can see it better. There we go. That's a lot better. Okay, there. Okay, so we're doing D. So D has an NH2, but it's connected to a carbonyl. So that makes a new functional group. When you have, it looks like an amine, and it looks like maybe a ketone or an aldehyde or something, but when you have this combination, that makes a functional group called an amide. So that's an amide. I'll write that there. And then what else? Well, that's all there is. That's an amide, okay? So there's nothing else on the rest of this is the an alkane or an alkyl part of the molecule. Let's go to F. So we'll do F down here. So what is F? So F is a molecule that has a C and OH connected to a saturated carbon. So there's the OH is connected to a carbon that only has single bonds. So this part is an alcohol. So I'm going to leave the rest of these for you to do. And good luck with functional groups. And if you have any questions, you can come to an office hour. Next office hour is on Thursday at 10 o'clock. So that's all for now. Only one lecture left. We're getting near the end. So take care, and I'll see you next time.